I have written the Cm phi m. C is with respect to constant. That's why that's come from this. Okay, and here the product formula will be applied. Okay, so the derivative of first, second as it, plus first as it, derivative of second. Okay. Okay. If you may remember it in this way, this is also easy. Or if you are interested to remember in the different way, that is, I think, if I multiply both sides with minus, okay, then this will become a Euler-Lagrangian equation. Okay, partial L over partial R dot K. You may remember in this way, or minus partial L over partial RK. Okay, if I multiply with the minus, then plus will be changed into minus and minus will be changed into plus. Okay. Plus that equal to 0. I think clear. Euler-Lagrangian form of Lagrangian, Euler-Lagrangian equation in the form of phi m, and derivative of Cm and derivative. And I think it is a more easy to remember. Okay. ये कैसे है? ये? Okay. Actually, you are interested by this equal to this. Okay. If I write RK minus that was equal to this. Okay, Cm phi m. Okay, this will be the integration. Okay, this was the result. Okay, Cn constant, so it will be come out this with respect to Rk. It will be come out, so it will be come out from this. Okay, and here Cm is also constant. It will come. हाँ ठीक है आंसर ये मैं डायरेक्टली किया ठीक है ये I know that firstly we have proved this ठीक है then I have put the Cm phi m in the instead of L that will be and that then it will you will get as Cm constant with respect to R that will be come out that will be equal to this okay and this become partial R over partial RK and in this case again Cm will be come out because it is constant with respect to R dot so it will be come out and this will remain the same but product formula will be applied here because you will be take the derivative of first okay and second as it plus first as it derivative of second okay and this is the form of I think it is easy to remember then I have multiplied with the minus okay so this become this and this become this and this okay I think they're very simple okay Because this is Euler-Lagrangian equation, this is also Euler-Lagrangian equation, so don't need to remember it. Okay? Multiply with the Cm and plus Cm plus pi m. Okay, so I think that is very simple. When we have multiplied with this, this will become plus, this become a minus. Okay, this become a plus, this become a minus, this minus become a plus. Okay. One minute. Again. Cm is multiplying with it. This is multiplication term. Okay. Bracket. Okay. When it multiply with this, this minus become a plus. ये term पहले आगे इसको plus आगे. This will become okay. Okay. I think now it is easy to remember. Have you noted it? Okay. So may I? It is recorded. Already recorded. I think. Okay. Okay. Next exercise is about if mass is moving in a okay. If mass, next exercise is if mass moving in three-dimensional space with constraint okay, Z. Okay. This is the constant given. Okay. And mass moving in a three-dimensional space. Okay. Yes. Z naught 3 and Y का. ठीक है. The constant may be changed in exam. Okay, so be careful about that. Okay. Yes. Okay. This is given. Okay. If a mass moving in a three-dimensional space with constant, and in paper the value may be a different. Okay. There may be a the similar example is also available in a YouTube, but that is with the different constant. Okay. I think there is a x naught, y naught, and left and button. Okay. So the value will be so similarly the value may be a change. Okay, in the exam. So must be careful and try to avoid the data. Okay. So how you will solve it? solution, mass moving in a three-dimensional space. Okay. Mass moving in a three-dimensional space. थोड़ा सा आगे कर लेते हैं, मुझे आप वैसे ही ज़्यादा चलाते हो, ठीक है. Mass moving in a three-dimensional space. Okay. For undergraduate level, the Lagrangian will be kinetic energy minus potential energy. That will be Lagrangian. That will be x. Okay, that will be a q and q dot. Okay, so that will be in three dimension. That will be 1/2 mv square, 1/2 m naught x dot square plus y dot square plus z dot square. This is kinetic energy. Okay, and minus potential you write, if I write in the form of V, because I am already using the phi. Okay, so potential is x, y and z, because it is moving in a three-dimensional space. So these are the conditions. Okay, since mass is moving in a moving with the constraint. Okay, okay, so आपने एक्सप्लेन करना, ठीक है. According to me, I think it must be kinetic energy. What is the kinetic energy? And you take. I have already proved it. That's why I would directly mention. Okay. I always, whenever I try to save my energy and time, but unfortunately I have to do it. Okay. So this is the Lagrangian. This is the constraint. Okay. Constraint is also given. Okay. So what will be the equation of motions? As we know that the equation is partial Lagrangian partial Rm minus partial L over partial Rm dot plus Cm partial L over sorry. Plus Cm dot partial phi m over partial Rm dot. Yes, that was equal to 0.
As the partial L over partial dot आ गया, तो left है, तो ये starting, ये dot आया, partial R
Okay, now it's okay. Okay, so this is your Lagrangian multiply method, and this is the equation. Okay, so L is here x dot, y dot, z dot, excuse me, sorry, x dot, y dot, z dot. So when we take derivative with respect to, okay, firstly, when we take the derivative with respect to Rm dot, what is the Rm? Firstly, the question is Rm. Rm is x, sorry, what is the R? Okay, Rm is R1, R2, because you are considering 3 dimensions, that is x, y, and z. Okay. Okay. So firstly, we will solve it for R1 equal to x. Okay. Okay. So when we solve it for x, so x dot Rm, here m is 1 only. Okay, because there is a single constant. Okay. There is something is missing. The indices must be a different. Okay. This indices must be different than this. I have already explained it many and many times. Why? The reason. That's what's confusing. Yes, that must be a different from. Okay. So this will be Rk. Okay. And R1 will be x. Okay. Now it's okay. Yeah, these are the derivative. Whenever you introduce the new, that will be different. These are the linear combination of phi m is the linear combination of the constants. Okay. And m is 1 here because only one constant. M is the number of the constants. Okay. So Cm will be equal to C and phi m will be equal to phi. So I may replace this all m with the okay, got it? Because m equal to 1, only one, there is only one constant. So Cm will be equal to C and phi m will be equal to phi. Yes, then you have to do. Yes, yes. So if R1 is x, okay, then what will be happen? 2x, 2 will be cancelled with the 2. Okay, so that will be m naught x dot, and derivative of x dot with respect to x dot, that will be a 1. Okay, and but when we take the derivative again with derivative with respect to time, that become a x double dot. Okay. Okay. So this term will be equal to this and x dot and minus partial level L is this. Okay. Partial L over x. Partial L over x. This sum will be 0 because there is no x. No, this here is minus x1. Minus v over x. Okay. Plus c. Here it will be not cm because m is 1. Okay. C and R dot is x dot. R dot is R is x, so R dot is x dot. Again, 2 will be cancelling. Sorry, this 5. Now the term is about the 5, not this. Okay. Partial of 5 with x dot, that will be z dot. Yes, when you take the derivative, that will become a double dot. Yes, because we are taking the time derivative. That will become a double dot. Okay. This 5 is the x. Either here x dot, z naught. Here is x naught, but not x. X naught is constant. z naught is constant. Okay, this is a variable. Okay, but derivative, partial derivative of y with respect to x is 0. Okay, so this become a 0. Okay, got it? Okay, so this will become, okay. Okay, plus c dot partial phi over partial phi is x dot, yes, x dot is this will be equation 1. Okay, now for R2 equal to y, R2 is y. Okay, so now this equation will become okay, this first term is as it m naught y double dot minus, okay, minus partial v over y plus cm c, yes, c the derivative of phi with respect to y dot y dot, there is no y dot, 0, but here is y, this is also 0. Okay, because no dot is involved. Okay, okay, so this is 0 minus partial phi over partial y. This 0, this will be minus minus plus 3 x naught z naught 3. Derivative of y is 1. Okay. If there is a square, then you know that what you have to do. Okay. Yes, sir. Okay, so you must be careful about that. Okay. Okay. So this become a plus. Okay. Okay. And this again y dot. There is no y dot, so this term is 0. Okay. So this will be a 0. Okay. So this will be the your second. Okay. Okay. These two terms is the same because only because 1 minute. This is the because these are the symmetric, so the result, there will be no change in this result. Okay, symmetric x will be replaced with the. The problem is here. Okay, this phi. When you take R2 is y. Okay, you are taking every term will be replaced with the y. Okay, so all derivative will be replaced with y. When you take derivatives, this is a phi. Okay, this is L, this is phi. So the second term is about the phi. Okay, constant. Okay, when you take with the derivative y dot, there is no y dot here, so that will be 0. So but here is y. Okay. Sorry, y dot. There is no y dot in this term, so first term will be 0. This first term will be 0. But when you take minus, then that will be here come a minus. Okay, and you take with derivative with respect to y. This term will be 0, but this is a constant. Okay, this is a variable. Derivative of y with respect to y is 1. Minus minus will become a plus, and that will be equal to this. Okay, the last is as you know, in 3 dimension, the R3 will be z. Now, okay, for Z, it is very clear. Okay. The first is again the same, because here is XYZ, here is also XYZ. Okay. So you have M naught Z double dot. Okay. Minus partial V over Z plus Z naught Z naught X dot आ जाएगा. When you take derivative with respect to Z dot, that will become X dot, and when take the time, that will become X double dot. Okay, with C. Okay. Minus Z. No Z. No Z. 0. Okay. This will be a 0. This will be a third term. Oh, sorry. Last was plus C dot.
Yeah, there is a X dot here.
C dot with respect to Z dot, that will be X dot. Okay. Yes. So that will be equal to 0. You have a 3 equations. Okay. So yes. C is not. C is not constant. C is function of time. I have already explained in the Lagrangian multiplier. C is the linear combination of the semi-holonomic constants. Okay, and that is not. You are right. That is the constant with respect to R and R dot. Okay. But the function of time. Okay. Actually, this is this. Okay. Now it's good. Okay. So. Okay, potential may be given. Okay, if you have a 3 equation and you have to find the value of X and X dot. Okay.
X and X dot.
Actually, you are interested to find the value of X. Oh, sorry, C. Constant. Constant force. Yes, that will give the information about constant force. Okay. So how you will find the C from? Okay. This is constant. I think you will get the C from, and putting this value, you will get the answer of the C. Okay. So these type of, for example, if I say that have you noted? If the question is mass moving in a 3 dimension, describe a mass moving in a 3 dimension, then what will be the equation?
The constant force will be
I have not mentioned this is the case for mass moving in a 3 dimension Cartesian space. Yes, you must be right. Because I am solving that, maybe I come in a polar coordinate, okay, and different, okay, in Cartesian. Because for simplification, I have taken only the Cartesian, okay. Okay, if the constraint is not mentioned, if there is no constraint, then what will be answer? Yes. Then that will be the solution. If no constraint, then what will be happen? No. Then your equation you have to solve by using the Atta-ul-Latif equation. Okay. Cm will be constant. Okay, and then yes, this is exercise 2. Yes, you are right. अब describe mass moving in 3 dimension in Cartesian space. Constant नहीं है, बस that is the difference. उसमें constant given थी, इसमें constant given, ठीक है? Okay. नहीं, question is different. In that question there was some constraint, but here is no constraint. If there is no constraint, then that will be equal to 0. Lagrangian equation, because the low Lagrangian multiplier method will be used. Okay. No constraint, and we have done this exercise in the previous 3-dimension math. You may remember that the kinetic energy will be 1/2 m naught xi dot xi. I have already proved, okay, in the previous, okay, and if there is not mass moving, there will be external force. Yes, what is the external force there? Because I am saying that Fq dot R. Yes, that was okay. That was I think. This equation will be applied, and this exercise is already done in previous lecture. Okay, and you know that the result was m xi double dot, that will be fi. I mean, if fm, then that will be fm. I have already proved that. Okay, in the previous exercise, I have already done it. Okay, if you forgotten, then you may move toward the YouTube channel, lecture. Okay, on this, the mass moving in 3-dimension space. Okay, these are not a moving free. Okay, that is in Cartesian space. Okay, if that is a free, then this force will be a 0, and you know what will be the result. Okay, got it? If that is a free, I have not mentioned free. Okay, free will be mean there will be no external force. Okay, so this external force will be a 0. Yes. Okay. Then force will become a 0. Yeah, nothing will be changed. Yeah. Okay, so actually potential become a 0. Okay? So right side become a 0. This Lagrangian. And this is not a Lagrangian, this is a kinetic energy. Okay, so sorry, correct it please. This is the kinetic energy. When you write in the form of force, this will be kinetic energy. Okay, okay, yeah, and this exercise already I have done this exercise. Okay. कहाँ की है? ये आपको क्या नाम है? साथ बताओ, ठीक है? Got it? Okay. May I remove it? Okay. The examiner may be a very strange person, so the question may come a very different type. For example, this question may also write in the form, if there is a free, then this force will be 0. And if it is written mass moving in three-dimensional sphere, and there may be a different type of question comes in exam. Okay. So sorry, no. Okay. Yes. Actually, you must use the spherical coordinate. Okay. And yes. Line theta. This is the third question. Okay. Now it's okay. Exercise 3. Okay. Sphere. A mass is moving in a sphere. Then what will be the solution? Okay, I think then the constant will be, what will be constant? X square plus y square plus z square minus r square equal to 0. This will be the constant. I mean, phi will be x, y, z. That will be a 0. Okay. This will be constant. Phi will be equal to, sorry, x square plus y square plus z square minus r square equal to 0. 0. Listen. Now it's okay. Okay. So, yeah. See, but in this case, if something is moving in a circle, luckily, spherical coordinate will be good coordinate. Okay. And in that case, the Lagrangian multiplier method will be not used. Okay. Yes. Why? Constant. No, constant. This is a given constant. No. Actually, Lagrangian multiplier method is for a semi-holonomic constant. So this is a holonomic constant. This is holonomic constant. Now phi is function of x, y, z, not function of x dot, any x dot or y dot is involved. So all term will become a 0. Partial phi. Partial r dot will be 0. Okay. It will be 0. Partial mean you don't need a constant. Okay. So that's because spherical coordinate for actually if you are interested to find the constant, then you will you may take add as a constant. Okay. And yes, this sum will become, but you may find the constant. But for bad coordinate, you may find the constant. But for good coordinate, if you change it into the spherical coordinate, the result is as the same. I have already explained in the mass moving in a three-dimensional case. Okay, so that will be the same simple answer. Okay, okay. So there are many different. You have to judge. That is the actually to explain these exercises. The reason is only to explain that the question may come from the constraint-free system, holonomic constraint. For example, if I write, yes. For example, if we write in a three-dimensional like a previous exercise, 100% like a previous exercise. If mass moving in a three-dimensional Cartesian coordinate. The exercise 4, okay. Cartesian coordinates with the constraint. What was the previous constraint? The exercise is the same as the previous exercise. That is, the phi is a function of x y minus 3. What was the 3? 3x x naught y z naught x z y naught 3 z. If this is the if this exercise comes in an exam, then what will be happen? Yes, please. It is written on the board. Acha, okay. First we answered it, and then what will be the solution? Your answer is absolutely wrong. I think today you are sleeping. Okay. Yes, he is wrong. I'm from it. This is a holonomic. No x dot is involved. So that will again. Yes. Okay. This is not a semi-holonomic constant. There is no derivative is involved. Okay. This is also example of holonomic constant. And we will use the dot coordinate and then we will solve it. Okay. So you will do it yourself. Okay. So these are all exercises. Okay. Actually, in last time we have done exercises. Okay. If the symmetry is like a spherical symmetry, okay, or a circle, okay, then you should know for circle the polar coordinate will be good and remaining will be same, okay. If the coordinate, if something is moving in a spherical coordinate, then okay. Usually I will try to mention that if the no constraint is given, then you know that what have to do, okay. I do a very important exercise that is belong to actually the semi-holonomic constraint, which I have already explained. Okay, that was about the exercise 5. Okay. No, you have to find. That is the your homework, your assignment. Okay. Okay. So that's good. The next exercise is exercise 5. Okay. Next exercise is if mass is moving, if describe a system, describe a mass moving spherical mass, spherical ball is rolling on non-slippery inclined plane. Okay. If spherical mass is if spherical ball is rolling on the non-slippery inclined okay, plane. Okay. Okay, so what will be the solution? Rolling on the inclined plane. Okay. Now, as we know, I have already explained it many and many times. If this is a 2-dimension and this is the plane, okay. So this is the plane, inclined plane, and if this is a sphere, okay. And if that distance is delta s, okay, Okay, this is total length is L. Okay, total length is L. If this angle is phi. Okay. Okay, you may say that that is L. Okay, you are right. Why I am writing this? I may say that that is delta L. Okay. Okay, and R is the radius of the ball. Theta is this is delta theta. Okay. Yes. Yes. If it has covered the distance delta L, this distance will be L minus delta L. L minus delta L. Okay. And okay, so for this system, you have constraint. What kind of the constraints you have? Constraint. What are the constraints you are applying on this? Because it is a rolling ball, so that will be followed that delta L will be equal to R delta theta. Okay, you must know how this equation is coming. Actually, mostly students draw the very wrong picture. Okay, so try to understand the concept of this picture. Okay, why this delta L is equal to R? Because this is the displacement delta theta. This arc length will be equal to this displacement. That's why that delta S mean actually this is delta S, and this delta S will be equal to del L, because when it roll it will be covered this distance. Okay, that's why this is equal. You must mention each and everything in the exam. Okay, but in the midterm exam, I'm very disappointed. Even your toppers. Okay, so you must explain. Yes. Yes. नहीं कितना पेज इतना ही ऐसी ना mention करो. You must. I'm not saying that you must write all the stories, but you have to mention. You have to describe that you are familiar with that. You know that what is going on that, because you must to present yourself. You know all the reasons. Okay? As this picture is explaining that this equal to this and this equal to this, at least you can draw this picture correctly. Okay, so explain. You must. The reflection should be observable at your paper, that you know each and everything and reasons and justifications etc. Okay. So because this delta L equal to this delta L equal to delta S, so this dl become R delta theta. Actually, this is the R delta theta. Okay. So change is, there is two type of the two variables. One is L and one is a theta. Okay. So because it is changing with respect to passage of time, so you will R is constant, so it will come out from the this, and when you take the limit that approach to delta t approach to 0, then that will be L dot will be equal to R theta dot. This will be constant. Okay. And your constant equation will become this implies that L dot minus R theta dot, that will be equal to 0. That will actually the weakly 0. Okay. Because this is itself 0, but the partial derivative will not 0, so that's why according to in a Dirac definition, not my definition. Okay, so that credit goes to Dirac. Okay, and So I will not interested to take the credit of drag. Okay, so drag is defined as weakly zero, and for reference you may study the introduction to quantum mechanics, the lectures of drag in I think Cambridge. I don't know remember, but the drag lectures volume 1. Okay, in quantum mechanics. Okay, so this phi will become, this constant is phi, and this will be x dot. Sorry, this is L dot theta dot, that is L dot minus R theta dot, that is weakly equal to 0. Okay. Yes. Okay. So okay. So when this will be equal to this, what will be the your L? Now you have to find L. L is kinetic energy minus potential energy. Okay, so L is equal to kinetic energy minus phi. Okay, V. Okay, potential. Kinetic energy. What will be the kinetic energy? What will be the kinetic energy? Kinetic energy of center of mass plus kinetic energy with respect to center of mass minus potential. Okay, minus potential is x. Okay. अच्छा, now the question is what is the potential? Potential क्या होगा इसका? Okay, yes, that will be a 2 dimension. Okay, yes, because it is in xy plane. You are right. Okay, in 1 minute, please. Firstly, I have to mention, then I will repeat. Okay. Okay. So what will be the potential? Potential क्या होगा? What is the firstly we write the kinetic energy. What will be the kinetic energy? The kinetic energy is 2 dimension. The kinetic energy. You are right. The actually QK is there is 2Q1 and Q2Q because it is 2 dimensional plane. You are right, and that will be here. That will be R and sorry L or L and theta always come. I have already in a polar coordinate. That will be L R theta dot. Okay, so sorry, theta dot. Yes, you are L and theta. Okay, L and theta. Yes. But in constraint R theta. Yes, you are right. Okay, the L and theta. Okay. Okay. Kinetic energy will be. I have already explained that kinetic energy is 1/2 m r dot square, 1/2 m naught r theta dot square. Okay, I have already explained in the previous exercise. That will be the kinetic energy. Okay, this is the kinetic energy. Okay, I have already explained in the polar coordinate form. Okay, in 2 dimensional plane. Okay, this is the kinetic energy. Okay, and now the question is what will be the potential energy? It has proved in the mass moving in a plane in the previous lectures. I am explaining that I have proved that the kinetic energy will be 2 part in 2 dimension. That will be r dot square and r theta dot square. That is the question, mass moving in a 2 dimension plane. Okay, in polar coordinate form. Yes, this lecture is available. Okay, if you are interested, I will be shared it on your group. Okay. Okay, what will be the potential? Potential क्या होगा? Potential is potential energy. Potential energy. This is a potential energy. What will be the potential energy? So what will be the potential? Yes, mgh. Potential energy is mgh. ठीक है? You are right. M naught gh. Okay. Okay. No. This will be mgh. ठीक है? This will be parallel. Okay. From center. Okay. Yes. And that will be equal to h will be equal to no. L minus r phi, that will be ओके. अच्छा ठीक है. आपको बड़ी परेशानी है उनकी. L minus delta L. Okay. This L minus delta L, and this is phi. Okay. And this will be what will be this? L minus delta L sine phi. Okay, h will be equal to this. This will be h. Okay. So m naught g L minus delta L. Okay, that the actually length is this. Okay, and the L minus this will be sine phi, not theta. This is different and this is different. You must keep in mind. This is phi, not sine theta. Okay. So this phi is constant with respect to theta. Okay. Okay. So this will be potential. So Lagrangian will become. So L will become. What will be L? 1/2 m naught r dot square plus r theta dot square. Okay. Okay. Minus m naught g L minus delta L sine phi dot. Okay. So this will be your Lagrangian. Okay. Now this will be this is a semi-holonomic constant. Semi-holonomic constant. This is the semi-holonomic constant, and that will be the equation of the Lagrangian. Okay. When you will combine both, okay, so you will get you have to write the there's actually this is typing mistake. Okay, so there's no typing mistake is very important in the lectures because it's always help you to catch your attention. Okay, so it always catch your attention, and not for paper, but it always why we always do the typing mistake in our board so that you can we can catch your attention. Okay, if you are sleeping, then you may awake. Okay, okay. So for today, I think you must try it in the. Okay, आपने वो constraint force वाली जो Lagrangian multiplier equation, you will use the Lagrangian multiplier equation, and you will put this value and you will get result. Okay, and definitely I will repeat it, but आपके लिए ये आपने पहले घर से करना है, ठीक है?